So here's another problem on integration. Now, this problem was actually testing on integration by parts, but then you are supposed to do some transformation to be able now to rewrite the integral into a very easy form that you can directly apply integration by parts formula. So let's see how the solution should have been. Now, the question is the integral square root of x e raised power square root of x dx. So you see these square root signs are scaring us. So what we do is try to eliminate them into the integral, but without watering down the content of the equation. So I'll say let's say w the square root of x. So which means that when I square both sides, I'll have w squared is given by x. So which means then to differentiating now both sides, left hand side will give me 2w dw equals to dx. So I can comfortably replace where there's dx by 2w dx. And then where there's root x, I put by w. So then this integral will be the integral of w and then e raised power w multiplied by where there's dx, I put 2w dw. Now you see by that transformation, we have put every variable in the integral to be in terms of w, the new variable. So which gives, I can factor out the constant 2. Then I have integral w by w is w squared, and then e raised power w, and then dw. So therefore now this part here is now in a very direct and proper form to apply integration by parts, or you can use tabular integration, which is actually just another modification of integration by parts. So we concentrate on integral of w squared e raised power w dw. So we let u to be w squared, and then dv to be e raised power w dw. So which means the u will be given by 2w dw, and v integrating e raised power w remains to be e raised power w. So which means integral of w squared e raised power w dw, integration by parts uv, u is w squared, v is e raised power w minus v du will be given by, so this is 2, I factor it out because I constant, so w e raised power w dw. And let me call this one 1, and let me call this one 2. Now in these two, this is also another integral that requires application of integration by parts. So integral of w e raised power w dw will be given by, so also let u to be w and dv to be e raised power w dw. So which means the du is the same as dw and v is the same as e raised power w. So uv will be given by w e raised power w minus v du will be the integral. V is e raised power w, du is the same as dw. Now this will just be the same as w e raised power w minus e raised power w. So this is the integral of w e raised power w dw. So let's call this one 3. So replacing 3 in 2, we have that the integral of squared e raised power w will be w squared e raised power w minus 2 into w e raised power w minus e raised power w, which is w squared e raised power w minus 2w e raised power w plus 2 e raised power w. So let me call this one 4. Now replacing 4 in 1, we get, so 1 is 2 integral of w squared e raised power w will be twice, and then w squared e raised power w minus 2w e raised power w plus 2 e raised power w. But then I just add c because this was an indefinite integral. So which will give me 2w squared e raised power w minus 4w e raised power w plus 4 e raised power w, then plus c. But you see, w was our own creation. So in terms of x, we have the integral of square root of x e raised power square root of x dx will now be given by 2 square root of x squared e raised power square root of x minus 4 square root of x e raised power square root of x plus 4 e raised power square root of x plus c. So which can be written as twice x e raised power square root of x minus 4 square root of x e raised power square root of x, and then plus 4 e raised power square root of x, and then plus c. So therefore, this was the answer to the required to the given problem. So it's simply an application of integration by parts, but then you have to do some transformation to be able to get the proper nature of the integrand. Thank you.